Hello there. This week we're going to be looking at a second form of quadratic functions. This one is called factored form. And while you've seen this before, I don't know that we've talked about the details very much. So that's what we're going to look at today. So factored form looks like anything of the form y equals a times x. And then I'm going to do this plus or minus p and x plus or minus q. And I will explain that plus or minus in just a minute here. But it's really got three parts. It's got a times an expression in parentheses and another expression in parentheses. So that a value is familiar. If a is positive, it tells us the parabola opens upward, right? Just like it did in standard form. That's actually the same exact a value. If a is negative, it means the parabola opens downward. And then inside those parentheses, those two expressions, what we can do is if we take the opposite value of P and Q, so those two numbers that are either added or subtracted to X, that will tell us the x-intercepts. Remember, there are two other words for x-intercepts. We can also call them roots, or we can call them solutions. I think today you'll hear me mostly calling them x-intercepts, but just remember that roots and solutions are other words you might see or hear. So let's take a look at this example, y equals x plus 3 times x minus 2. And I just want to start with the a value here, because we don't really actually see an a value, but I just want us to keep in mind that just because we don't see an a value doesn't mean it's not there. We have a ninja 1 in front of those. It's not going to be very useful. We don't need it. That's why it's not written. But it is helpful to remember that knowing that a is 1 will tell us that our parabola will open upwards. Now, the slightly more interesting pieces here is where this says x plus 3 and x minus 2. So we've got these two numbers in here. And if we think about what this is, if we think about the value minus 3 or positive 2, taking those opposite signs, those actually tell us our x-intercept. And if we look at the graph over here to the right, well, we've got an x-intercept at negative 3, and we've got an x-intercept at positive 2. It's the same equation graphed right over here, and so we have our intercepts formed. Now you might be asking yourselves, why? Why does this work? And it comes down to something called the zero product property, which we're going to explore a little bit later. But let's remember that an x-intercept is where the y value is equal to 0. So if our equation is y equals x plus 3 and x minus 2, then we're looking, where does that expression equal 0? Now, if I told you something like a times b is equal to 0, the only way to get two numbers equal to one another is if a is equal to 0 or if b is equal to 0. And so it's the same thing here. Either one of our expressions has to be equal to 0. Now, if if let's say x plus 3 would be equal to 0, we would get an answer, x equals negative 3. And check it out, that matches the x-intercept that we identified. If we were to say that x minus 2 is equal to 0, then we'd get x is equal to 2, which, ta-da, matches our other intercept. So I'm not going to ask you to do all of this work by setting things equal to 0, but I just wanted you to see the background information of why this shortcut works. So just like our standard form, right, we have some information. We have an a value, we have our intercepts, but that's maybe not all that we need in order to build a parabola. So we're also going to use the factored form to find the vertex. Because it turns out the vertex is kind of important, pretty helpful. So just like with standard form, we're going to start with the x-coordinate of the vertex. And what it is it is the average of the two x-intercepts. And so when we say average, remember how you find an average with statistics is you add numbers up and divide by the total number of values. So what we would do here is we would add the x-intercepts together, then divide by 2, right? If there are two x-intercepts, we'll add them together and we'll divide by 2. And then to get the y coordinate of the vertex, well, we've done something like this already. Once we have the x-coordinate, right, we plug it in. We plug in the x value into the equation and we evaluate. We just figure out the resulting number. So we're going to do a couple of examples here practicing that. And so we're really practicing two things. We're practicing the x-intercepts, and then we're going to use that to practice finding the vertex. So this example, f of x equals negative x plus 1 and x minus 2. Remember that negative 1 is really a negative ninja 1, an a value of negative 1. So our parabola will open downwards. Based on the expressions inside the parentheses, we're going to have the x-intercepts at x equals negative 1 and x equals positive 2. We're going to use the opposite sign as what's in there. And so we need to find the x value of the vertex. So we're going to do that by adding these two numbers together, negative 1 plus 2, and then we're going to divide that by 2. So negative 1 plus 2 is equal to 1, and we divide that by 2 and we get 1/2 or 0.5. So we have part of our vertex, and now we need the y value. So we're going to substitute 1/2 or 0.5 in directly to our equation, plus 1 and 0.5 minus 2. Now, I like to simplify everything first, right? The order of operations says that we should simplify our parentheses first. So I'm going to have negative 1 out in front, 1.5, and then 0.5 minus 2 is negative 1.5. And if I were to plug all of this into my calculator, right, this is just negative 1 times 1.5 times negative 1.5, we would get positive 2.25. So our vertex is at the coordinate point 0.5, negative 2.25. So it does take just a little bit of practice to get used to finding those x-intercepts first. But again, we're going to do a few more examples together just to make sure that this is something you're comfortable with. So let's take a look at, this time we're actually going to graph a parabola, which means we're going to utilize all of those other features. So we are graphing y equals x plus 4 and x minus 6. So again, we have an a value of 1. That's not going to impact our graph other than to tell us what direction it opens, which is upward. So we'll just keep that in mind. We have x plus 4 and we have x minus 6. So our x-intercepts are at negative 4 and positive 6. And really, remember, those are going to be coordinate points where those are the x values. So I'm going to plug in those, or I'm going to plot those points, excuse me. Come on, do. All right, I'll try plotting 6, 0 later. For some reason, my stylus isn't responding here. Oh, there it is, perfect. Okay, so the reason that we use the average to find the vertex is because we want this right down the middle. We know that the axis of symmetry goes right down the middle and the vertex will be along it. So using the average helps us to figure that out really quickly. So negative 4 plus 6 is 2, divided by 2 is 1. So we have an x value of 1, and I could also think of that as being, right, my axis of symmetry. If my axis of symmetry goes right down x equals 1, then my vertex will be along that line also. So I'm going to plug in 1 plus 4 and 1 minus 6. So that will give me 5 and negative 5. So my y value is actually equal to negative 25. So my vertex is at the coordinate point 1, negative 25, which, as it turns out, is not on my graph, right? It's somewhere well below this graph. But that's okay. I think we can look at a few other points, maybe some that are just a bit closer to our x-intercepts here to help us see what the rest of the picture is going to look like. So I wonder what happens when x is equal to 5, because I know that my parabola is going to go, and this is just my rough sketch, it's going to go, down like that because it's got to go all the way down to 1, negative 25. So I'm curious what happens exactly along the way. So when x equals 5, let's see, we get 5, oops, yeah, 5 plus 4, really? Okay, 5 plus 4 and 5 minus 6. So 5 plus 4 is 9, 5 minus 6 is negative 1. So I'm going to get the coordinate, I'm going to get a y value of negative 9. So my new coordinate point here is 5, negative 9. 5, negative 9. And then remember the axis of symmetry lets us have a pair on the other side. So exactly across from that is negative 3, negative 9. So maybe this graph isn't the most satisfying picture here, but it lets us know in general kind of what's going on here. Maybe I'll just add this sketch so that I know that my vertex is at 1, negative 25. Let's try this next example and see how it goes, and this will also let us remember some of our other features here. So we've got a quadratic function, y equals negative x plus 1 and x minus 5, and I'm actually going to start with the x-intercepts, not the vertex, because they're given to me right away in factored form. So my x-intercepts, remember, are going to be the opposite there, x equals negative 1 and x equals positive 5. So I'm going to have the coordinate point negative 1, 0, and 5, 0. And again, I just like to start with those on my graph so I can see, where everything else is going to be hanging out there. So I need to find my vertex. My vertex will be exactly halfway between those. So negative 1 plus 5 divided by 2. Negative 1 plus 5 is 4, and 4 divided by 2 is 2. So I have an x-coordinate of 2. And my y-coordinate, remember that negative sign? It's actually a negative 1. And if it helps to remember to actually write that out, please do so. I would rather you write it out than forget what it means. So this will be negative 1 times 2 plus 1 is 3 times negative 3. Negative 1 times 3 times negative 3 is positive 9. So my vertex is the coordinate point 2, 9. So this time we are on the graph. So this will be a slightly more exciting picture. And we found the vertex. We also found the axis of symmetry. We could have added that in at any point in time. So that axis of symmetry is the vertical line x equals 2 because it matches the x-coordinate of the vertex. I think having another couple of points here might make our picture just a bit more interesting. So I'm going to see what happens when x equals 3 and what happens when x equals 4. And I'm just going to rewrite my equation so I can use it. Okay. So when x is 3, we have negative 1 times 3 plus 1 times 3 minus 5, which is negative 1 times 4 times negative 2, aka 8. So we have the point 3, 8. And then when x is equal to 4, we have -1 times 4 plus 1 is 4 minus 5, so that's -1 times 5 times -1, which is going to be a positive 5. So the 0.45. Oops, I forgot to plot my vertex. Oh no, I did. It's up there. Okay, so the 0.38 also gives me a point for free. On the other side gives me 1/8. And then the 0.45 also gives me another point for free on the other side, gives me the 0.05. Remember, I need at least 5 points to make a graph. If I can, I think my graph up above had 4 points with the 5th point off the graph. But now I think this graph is pretty complete, pretty satisfying there. And we can definitely talk about the domain and the range. So remember, the domain for a parabola is going to be all real numbers, or we can use that R symbol there. And then our range, it goes all the way up to 9, but not past it. So our range is y is less than or equal to 9. All right. So factored form, it's just maybe a couple of extra steps here to find those pieces, but it's the same pieces that you were looking at last week with standard form. So there's one more video I'd like you to check out, and it's going between factored form and standard form, and then I think you'll be ready to do your practice assignment. So take care, and I will talk to you in a little bit.